is. So here we have some sample problems to look at. First one just says, write this as a ratio of whole numbers in lowest terms. So first step, we don't need the dollar sign, so we're just going to put 0.40 over 0.30, and then we'll try to clean it up a little bit. Now, reminder about decimals. When I say 0.40, that's slang. The correct way to read it is to look at the place value and read it from there. So that's the tens place, that's the hundreds place. So technically that's 40 hundredths divided by 30 hundredths. Okay. Or you might say, well, those extra zeros are kind of not needed. So I could write it like this. 4 tenths divided by 3 tenths. Now we know that playing with fractions, we can make a similar fraction by just multiplying top and bottom by the same thing. So here I might just multiply top and bottom by 10. And so that's going to give me 4 over 3. And so now I have a ratio of whole numbers, and 3 and 4 have no common factors. So that should be the reduced version of it. And on some of these, you can just plug right into the calculator. Some calculators have a fraction button. My favorite calculator does. So I'd recommend doing 2 things with these problems. Write it on paper, try to do it without the calculator, and then whip out your calculator and do it with the calculator. So I'm going to open up Desmos. Scientific. So if I just type 0.40 divided by 0.30, my lovely friend Desmos has this fraction button, and it says 4/3. Pretty cool. So use your fraction button on your calculator a lot, but also practice writing it down without a calculator. All right, next. Spend 2.5 hours a week studying for English and 3.5 hours studying for math. What is the ratio of time you spend studying math to English? Order is important here. They said math to English. Sometimes we use a colon, so math colon English. Or as a fraction, it would be math over English. And sometimes when I'm playing around with proportions and ratios, I write it out in words, what's in the top and what's in the bottom. And that helps me. Here, it's not too much of a big deal. Bottom line, though, is because of the order they said there, then the math number has to go on the top. So that would be the 3.5 for my version. Next thing, they're probably going to want a proper fraction. That ain't a proper fraction because it's got decimals in it. So what could we do to tweak it?
Multiply by 10.
Multiply by 10. There we go. Great idea. Right. Which shift the decimal point. Right. You could just shift the decimal point, which means you multiply by 10 in your head. 35 over 25. Can we reduce that? Sure. Divide by 5. Another tip, since we got a test coming up soon, write down things like divide by 5 instead of just thinking it, because it's really hard to reflect on your thoughts, and it's really easy to reflect on what you wrote on the paper to see if you're right. Okay, so 35 divided by 5 is 7, 25 divided by 5 is 5, so 7/5 would be the reduced ratio for this. How would we check it? Whip out Desmos, right? Type this in, hit the fraction button. All right, next. This here, when we draw a picture of some kind of ratio, is either called a bar model or a tape diagram. And they can be really helpful in solving these kinds of problems, where we have a little bit of information about how two things are related and then other information about how they might have changed. So here they're showing me a picture of the ratio of 5 cats to 7 dogs. And they're saying, okay, we rescued 35 cats. How many dogs did they rescue? Assuming they always have the same ratio. So a couple ways to solve this. One would be to just set up a proportion, where I would write something like, what's the missing thing? Cats or dogs here? Dogs. So since dogs are missing, I would write dogs over cats instead of the other way around, because it's going to be easier to solve. And then initially they told me that there are 7 dogs for every 5 cats. They want me to figure out how many dogs go with 35 cats. And then there's at least 2 ways to solve this from there. We might be able to just look at this and say, oh, I know how to get from 5 to 35. Right? I would multiply by 7. So I could do the same thing here, multiply by 7 to keep things in proportion. So there ought to be 49 dogs then. Sometimes it's not so easy to guess that multiple right there, in which case I would solve it like this. 7 over 5 equals what over 35? Since the missing number is in the top, all I need to do is multiply the 35 up. And so then on my calculator, I would just say, okay, what's 7 times 35 over 5? Another way to do this is to use the picture. So the picture, I can choose to mean that this bar for cats represents 35. If this whole bar is 35, can I figure out then how much each of those is worth? How many of them are there? There's 5 of them. Well, I know that 5 goes into 35 7 times. Oops. Do a pen back. 35 divided by the 5 blocks I have there is 7. So that means each of these blocks here must be worth 7. And the point of the tape diagram is that every block that size should be worth 7. So that means all these guys should be worth 7 too. How many 7s are there for the dogs now? Yeah, there's 7 of them, so there must be 49 of them. So it turns out I don't even have to resort to a proportion if I have a picture like this. I can just do a little bit of arithmetic and then fill in the boxes. And you will see this a lot in elementary school worksheets, where they have problems like this that look kind of complicated, but it turns out they can just do a little bit of work and then fill in boxes and come up with an answer, which is kind of fun. All right. Christian, welcome.